Now in SQL, there are commands to manage transactions, including to abort them. And I would like to stress once again that SQL and transactions are independent things. You don't need SQL to want transactions. You may want SQL without transactions, that's all fine. But SQL and transactions are often bundled together in relational databases. And so briefly, let me mention how the SQL language supports transactions from a language perspective. The basics are, before a block of SQL statements, you can say begin, and that begins a transaction. And when you're done with your block of SQL statements, when you want to commit, you say commit. If you don't want to commit, you can say rollback, and some systems will also allow the keyword abort, and that will abort the transaction. SQL also has a notion of save points. In the middle of a transaction, you can issue a save point command and give the save point a name. And then when you have a save point in your transaction, there's two things you can do with that save point. One is that you can release the save point, which makes it as if the save point never existed. Okay. But the other thing you can do with the save point is you can roll back to that save point. It's like a partial abort just to the save point. All statements since the save point are rolled back. So let's look at the example transaction down at the bottom of the screen. It starts with begin, so we know that the next block of SQL statements are all part of the same transaction. We insert into table 1 a value yes1. We issue a save point sp1. We insert into table 1 values yes2, and we release the save point sp1. This has the effect of making it as if there never were an sp1 save point. Now we declare a new save point sp2. We insert into table values the string no, and then we roll back to save point sp2. All right, that has the effect of undoing everything that happened since that save point, namely the insertion to table 1 of the value no. And then finally we insert into table 1 the value yes3, and we commit. At the end of this transaction, table 1 will contain yes1, yes2, and yes3, and it will not contain the value no. All right, here's another example of rollback with SQL integrity constraints. And this is a constraint violation that'll roll back a transaction. What we're looking at here actually is a screenshot from running this transaction in Postgres. So we begin with a begin transaction. We create a table sailors, which has a primary key SID. We create a table reserves, which has a foreign key referencing sailors, which is also called SID. We insert into sailors the value 123, Popeye. We insert into reserves a value that has Popeye reserving boat number 1 on July the 4th, 1776, and we commit. Okay, so that's the state of our database right now. We have Popeye and a reservation by Popeye on July the 4th, 1776. Now we begin a new transaction, and we try to delete from sailors all the sailors whose name starts with P. And you see we get an error from Postgres. It says, update or delete on table sailors violates the foreign key constraint, which has a name that was given to it by Postgres, on the table reserves. In particular, the key SID equals 123 is still referenced from table reserves. So it's very specific about what value was contained in dangling pointers in reserves. Okay, and so you can see that we can try a new command, insert into sailors values 124, olive oil, but Postgres will tell us, look, the current transaction has already been aborted, and any commands will be ignored until the end of the transaction block. When we try to commit, what's going to happen is Postgres actually isn't going to commit anything because of the constraint violation earlier on. And when we do select star from sailors, we'll see that olive oil did not get inserted. Only Popeye is there, as it was at the beginning of the transaction. You may notice here that when we said commit, Postgres didn't say anything back to us. And the only reason for that is I turned off some of the messages from the Postgres command line because I wanted this to fit on a slide. Ordinarily, the commit would have given us a message to say that it had failed. Now, why did database systems crash? Well, here's a bunch of reasons in decreasing order of frequency. The most common reason databases crash is operator error. You know, the classic example is tripping over the power cord, and that can certainly still happen if you don't set up your machine room well. On the right, we have a picture of a modern server rack, and this is the way you're supposed to wire up a bunch of servers. Right, all the wires are tucked in. They're all in a scenario here where there's no way for an operator to actually trip over them. But it's certainly not unusual for a system administrator to go into the machine room and either power down or unplug the wrong machine. So that trip over the power cord, you know, by that I mean misconfigure the hardware in some way, unplug the wrong cable. Another thing that operators often do, right, is to type the wrong command. You thought you were shutting down one database instance, you instead were shutting down another one. You accidentally deleted the files where the database was stored. You know, these kinds of things do happen. They shouldn't happen, and in a very well-run shop, they're very hard to make happen. But operator error remains the most common source of any software crash. Another reason that databases fail is configuration error of the software. A typical one is that the database system grew bigger than the resources that were allocated to it. For example, we ran out of disk space, either for the database or for the log. Another possibility that comes up is that file permissions weren't set properly in the operating system. So the database was off trying to allocate a new file to store some more table space, and it didn't have permission to do that. These kinds of scenarios that span both the configuration of the database and the configuration of the database within the operating system are a reasonably common source of error, and they don't always appear right away. Sometimes they unfortunately only appear later on. The third cause of error is the one you might have thought of first, but it's actually not that common, and this is software failure. Either the database has a bug in its own code, or some security flaw allows someone to bring down the database, or perhaps you triggered an operating system bug. These things for sure happen, but not as frequently as the things above, okay? Finally, actually the least common source of failure is a true hardware failure, where either your media fails, a disk drive fails, or a server fails. If you're using magnetic disk, which a lot of large-scale cloud databases are doing, disk drives do fail with some frequency, but most disk drives, A, have early warning signs of failure, and those tend to get bubbled up to operators, and B, many disk drives are bundled into redundant packs of 2 or 3 disks in a RAID style. If you haven't learned about RAID, that's a good thing to know about, redundant arrays of inexpensive disks. And so media failure is usually hidden pretty well, or it's at least predictable. And then server failure, the idea that sunspots caused your CPU to do something funny. I'm sorry to tell you that that rarely happens. So it's usually a problem with software configuration, or most commonly simple operation of the systems.